Welcome YouTubers to another episode in my Grammar Hero series. In this video I'm going to be working out practice problems from the arithmetic reasoning section of the Asvab. Before I do that, I just want to make a few comments about the Asvab itself. The Asvab, as you can see here, is broken down into 10 subtests, including general science, word knowledge, and so on. What's more, you're given a different amount of time to complete each subtest. For example, to complete the arithmetic reasoning section of the test, you're given 39 minutes to do 16 questions, whereas the other times vary for all the other sections. Similarly, you'll be given either one of two versions of the Asvab. That is, you'll either receive the CAT Asvab or the P&P Asvab. CAT Asvab simply stands for Computer Adaptive Test, whereas P&P stands for Pencil and Paper. Nowadays, they only give the CAT Asvab, so more often than not, you'll likely receive that version. In case you don't know what Computer Adaptive Test means, it means your first question is moderate in terms of its difficulty. If you get it right, the next question's slightly harder. And if you get it wrong, the next question that you receive slightly easier. And it pretty much progresses like that throughout the test. Okay. What's more, once you complete the Asvab, you're going to be given scores for each of those 10 subtests, as well as an Afqt score. Afqt stands for Armed Forces Qualification Test. And it's the score that says this person is yes, qualified to join the military, or no, not qualified to join the military. More specifically, the scores made up of the 4 composite scores, specifically the word knowledge section, the paragraph comprehension section, the mathematics knowledge section, and the arithmetic reasoning section. Those 4 composite scores are put into a formula, and then you're ranked against how others perform on this test. In other words, if you score 99, that means you scored better than 99% of all test takers. Okay. In general, you want to score at least a category 3 or above. There are some limits in terms of what recruiters can do if you score below that. Similarly, I want to point out that these 4 sections are very important to your career in the military. As long as you do well on these 4 sections of the test, your chances of getting the career that you want are very high. So instead of wasting your time studying how to assemble objects or mechanical information, I would devote 100% of your time to studying these 4 sections. Everything else will fall into place. Okay? One comment regarding studying, I would say before you take the real Asvab, you should take at least 10 full-length practice tests before then. Okay? So all that said, let's go ahead and get started with today's video. Again, I'm just going to work out 16 problems, and I'm going to work very slowly. More specifically, I am going to take the time to work out long division problems, long multiplication problems, and so on. That way, if you're rusty in those areas, by watching this video, you'll know what you need to improve on. Question number 1. Patty is 45 years old. She is 15 years older than twice her daughter's age. How old is Patty's daughter? Okay. The chances of you seeing a question like this on the Asvab are pretty high. We know Patty is 45. So let's just say P is equal to 45. We don't know how old her daughter is, so let's say we don't know her daughter's name either, so we're going to say her daughter is X years old. So that means Patty is twice her age, that is 2X, plus 15 years. How old is Patty's daughter? Okay, that's the question. So if Patty's 2X plus 15 years older than her daughter, let's go ahead and make this into equation and solve it. 45 equals 2x plus 15. Okay, that gives us 45 equals 2x plus 15. Let's subtract 15 from both sides. This goes away. 15 minus 15, 0. 15, or 45 minus 15 becomes 30. We still have this 2x over here. To get 2x by itself, we divide both sides by 2. 2 divided by 2 becomes 1. 30 divided by 2 becomes 15. 15 equals x. And over here I said her daughter's age is going to be represented by x. So her daughter is 15 years old. If we plug this in, again, Patty's twice as old. 15 times 2 is 30. And another 15 years on top of that, twice as old. 30 plus 15 is 45. So the math checks out in this case. On number 2, Patrick was going to buy a car for $5,800. The car dealer offered him 2 options for buying the car. He could pay the full amount in cash plus 10% for tax and license, or he could pay $1,000 down and $230 a month for 24 months. And the dealer would pick up the tax and the license cost. Which is the better deal? So let's just work these out one by one and find out the better deal. So I'm going to call this deal 1. He paid $5,800 in cash and 10% for tax and title. So we need to add the cost that he paid in cash plus the tax amount. So we know that's $5,800. That should be a comma, times 10%, or 0.1. Again, you need to know to do these problems that 1 over 10 is the same as 0.1, which is the same as 10%. Okay? When you multiply decimals, the trick is to make this a whole number. Remember how many decimal places you moved. You moved it 1 in this case. At the very end of this multiplication problem, we'll add that back in. So 1 times 0 is 0, 1 times 0 is 0, 1 times 8 is 8, 1 times 5 is 5. 1 decimal place we moved, so we're going to add that back in. This is $580. In other words, Patrick paid $580 in tax. That's in addition to the $5,800 he paid in total. So let's go ahead and add those together. To find the total for deal 1, 0 plus 0 is 0, 0 plus 8 is 8, 8 plus 5 is 8, 9, 10, 11, 12, 13. Carry the 1, 5 plus 1 is 6. So in total, he paid $6,380 for deal 1. Deal 2. We know he's putting $1,000 down, so we'll add that in at the end. And he's paying $230 over the course of 24 months. So we need to find out how much that is. This is a simple multiplication problem. 4 times 0 is 0. 4 times 3 is 12. Carry the 1. 4 times 2 is 8. Add the 1. That's a 9. In multiplication, whenever you start a new row, you add a 0. 2 times 0 is 0. 2 times 3 is 6. 2 times 2 is 4. Let's add this up. 0 plus 0 is 0. 0 plus 2 is 2. 9 plus 6 is 15. Carry the 1. 4 plus 1 is 5. So this is the cost for the $230 over 24 months. Remember, he put $1,000 down, so let's add 1,000 to that. 0 plus 0 is 0. 0 plus 2 is 2. 0 plus 5 is 5. 5 plus 1 is 6. So for this deal number 2, he paid a total of $6,500, $6,520. Okay, 6,300 is less than 6,500, so we know deal 1 or the cash plan is cheaper. A rectangle with a square area of 60 square inches is 4 inches longer than it is wide. What is the width of the rectangle? So we got a rectangle, looks something like this. We know the area is 60. How do you find the area of a rectangle? In case you forgot, it's length times its width. In this case, we're given neither of those pieces of information. Instead, we're told that the length is 4 inches longer than the width. I'm going to represent width with an x since it's unknown. Since the length is 4 inches longer, I'm going to make this 4 or x plus 4. Now we can do some math. Let's go ahead and plug these two variables into our area formula. So area equals x times x plus 4. Again, I just plugged that right into this equation. What's more, I know the area is 60, so A is equal to 60. Let's fill that in this next line. Okay. Now I got to distribute this x specifically to here and here. So 60 equals x times x is x squared. X times 4 is 4x. Okay, now we have a quadratic equation. The only way to solve these is via the quadratic formula, graphing, or factoring. The quickest way, as I'm sure you know, is by factoring. So to get it set up to factor, I have to move this 60 over here, so I'm going to have to subtract it from both sides. 60 minus 60 is 0, and we just subtracted it off the end here, so we're left with 0 equals x squared plus 4x minus 60. Okay. To put this in a form you're used to, I'm just going to rewrite it one more time. X squared plus 4x minus 60 equals 0. Now we're going to factor. If you remember how to set that up, it looks like this. To fill in the blanks, which are right here and here, you're saying to yourself, what can I multiply to get negative 60 that adds to positive 4? Again, what can I multiply by each other to get negative 60 but adds to negative 4? Let's do a positive 10 and a negative 6. Again, negative 6 times 10 is negative 60, so it checks out there. 10 plus negative 6 is positive 4, so it checks out there. So these are going to be our two factors. Now we take these and set them to equal to 0 separately. X minus 6 equal to 0. X plus 10 equal to 0. Solve by simply moving this 6 over. X is going to be 6. Solve by moving this 10 over. X equals negative 10. Okay. Since area is in regard to real shapes, we can't have a negative number, so we know this isn't going to be a solution. We know x is going to be 6, so in other words, we know 6 is going to be the width. We know the length is 4 inches longer, so that's got to be 10. The question is, what is the width? 6. I forgot what number this is, but let's just go with it. In the town of Powersville, all the license plates have 4 characters. The first character is always an R or a P. The second and third characters are digits between 0 and 9. The fourth character is a single letter of the alphabet between A and Z. How many possible license plates are there? Okay. So let's try to do this one visually, since a lot of you probably haven't seen statistics in a while. Again, on the license plate in this town, there are 4 blank spaces. 1, 2, 3, 4. Okay? In the first one, the choices are R or P. And I put R twice. That should be a P. Sorry about that. In other words, there are 2 choices here. In the second and third blank spaces, there are 10 choices. That is 0, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. Again, 0 to 9 is 10 choices. Again, that applies for here and here. In the fourth space, there are 26 choices. Again, from A to Z, there's 26 letters in the alphabet. To find out how many different possible combinations are, there are, you simply multiply these all together. 2 choices times 10 choices by 10 choices by 26 choices. And this turns out is not that hard to do mentally. 10 times 26 is 260, times 10 is 2600, times 2. So let me just work this last part out for you. 2600 times 2, 2 times 0 is 0, 2 times 0 is 0, 2 times 6 is 12, carry the 1, 2 times 2 is 4, plus 1 is 5200. There are 5200 different types of possible license plates, given all the different parameters set on this question. Okay? John wants to buy a new computer that cost $3,280. He decides to use his own car and hire out as a taxi during the 4 months of the summer. It cost him $693 to insure his car for those 4 months. He spends $452 per month on gas. Assuming no other expenses, how many fares will he have to get before he earns enough money for the computer if he charges an average of $7 per fare? Okay, so we know the computer cost is going to be $3,280. We know he's going to use his car as a taxi. That's going to cost him $693 for 4 months. So let's add that into the total he's going to have to spend before he can afford the computer. 0 plus 3 is 3. 8 plus 9 is 17. Add the 1. 6 plus 2 is 8. Plus 1 is 9. Bring down the 3. And we're told that it's going to cost him $452 in gas for the 4 months during the summer. So let's go ahead and work that out. 2 times 4 is 8. 5 times 4 is 20. Carry the 2. 4 times 4 is 16. Add the 2. 18. So let's add that into our running total here. 3 plus 8 is 11. Carry the 1. 7 plus 1 is 8. 9 plus 8 is 17 again. Carry the 1. 3 plus 1 is 4. Plus 1 is 5. So all told, he's going to spend $5,700, $5,781 for the 4 months during the summer. We know he charges $7 per fare. So let's go ahead and do the long division to find out how many fares it's going to take for him to purchase the computer, including all the cost it takes him to earn the money. So we're going to do long division here. I'm going to do it slowly in case people haven't seen it in a while. What times 7 could get us close to 5? Nothing except a fraction, which we can't do for long division. What times 7 will get us close to 57? 7 times 7 is 49. 7 times 8 is 56. So we're going to go with 8. Subtract it. 57 minus 56 is just 1. And you just bring down the 8 and the 1. Simply just drop that down. Now we're saying what times 7 could get us close to 1? Nothing except a fraction. Can't do that. What times 7 will get us close to 18? 2 will get us 14. 3 will get us 21. So we're going to have to use 2. We can't go over. 7 times 2 is 14. Subtract it out. 18 minus 14 is 4. Bring down the 1. We can stop right here if we wanted to because we already know what the answer is going to be. But let's just work it out for practice. Again, we already dropped down this 1. What times 7 will get us close to 41? That's going to be 5. That would get us 35. So we know this answer is going to be 825 and some amount of change. In other words, $826. Or 826 fares at $7 per fare will get him enough money to purchase the computer as well as the cost he incurs to save up for the computer. So the answer is C. Rod is a very fast runner. One day he ran 100 meters in 40 seconds, 200 meters in 1 minute and 10 seconds, and 200 meters over low hurdles in 1.5 minutes. How many more seconds did it take him to run the 200 meters over low hurdles than it did to run 200 meters, the 200 meter dash? So we're given 3 pieces of information in this case. We're told it takes him 40 seconds to do 100 meters, a minute 10 to do 200 meters, and a minute 30 to do 200 meters with low hurdles. Question is, how much longer does it take him to do the low hurdles than the 200 meter dash? So we're not interested in this first piece of information at all. If you wanted to make this math simple, you can convert these all to seconds and then just do subtraction. Again, there's 60 seconds in a minute, so 60 plus 10. A minute 10 is the same as 70 seconds. And in this case, we got a minute 30, so we got 60 plus 30. A minute 30 is going to be 90 seconds. You can subtract this out if you want, but clearly you can see that it takes him 20 more seconds to do the hurdles than just the 200 meter dash, which is D. Triangle with a perimeter of 60 inches has one side that's twice as long as the shortest side and a third side that's 8 inches longer than the shortest side. What is the length of the shortest side? Okay, so we got some triangle. Doesn't matter what it looks like. We're given all this information about its sides, but we're not told specifically what any one side is in terms of length. But we are told that its perimeter is equal to 60 inches. And to find a perimeter of a triangle, we simply just add up its 3 sides. That is side plus side plus side. And in that case, that would be side plus side plus side. We can't do that because we don't know what these sides are. So let's go ahead and try to make this into something we can do. I'm going to represent the shortest side as x. And we're told that one side is twice as long as the shortest side. So if the shortest side's x, twice as long as that is going to be 2x. And we're told a third side is 8 inches longer than the shortest side. If the shortest side's x, 8 inches longer than that's going to be x plus 8. Now we can plug things in. Again, perimeter is side plus side plus side. So we have perimeter equals x plus 2x plus x plus 8. We know the perimeter, or P, is equal to 60, so let's plug that in as well. 60 equals x plus 2x plus x plus 8. Combine like terms, 60 equals x plus 2x plus x. X plus 2x is 3x, plus x is 4x. Then we just have that 8 hanging out there. Let's keep reducing. I'm going to subtract 8 from both sides. 8 minus 8 is 0. 60 minus 8 is 52. Still left with this 4x. Divide 4x by 4. What you do to one side, you have to do to the other. This crosses out. We're left with x equals 52 divided by 4. Now we need to reduce that. If you're not good with times tables, you can turn this into long division. 52 divided by 4. 4 goes into 5 one time. 4 times 1 is 4. Subtract. 5 minus 4 is 1. Bring down this 2. 4 goes into 12 3 times. So we know x, which represents this short side, is going to be 13. Your commander orders you to fly a weather balloon at the end of a 500-foot string. Your first sergeant comes out of a nearby building and stands directly under the balloon 300 feet away from you and yells, "How high is the balloon?" Assuming the ground is level, what is the correct answer? Okay, so let's draw a little sketch. Here you are. you're holding a string that's 500 feet long. And we're assuming also that you've let out all the string. Here's the end of your little balloon. And the sergeant comes out and he's directly under the balloon. Say, here he is. And he's 300 feet, according to the problem, away from you. How high is the balloon in the air is the question. So again, unknowns I like to represent with x. In other words, how high is that distance, x? This, it turns out, forms a right angle with the ground, and we can use the Pythagorean Theorem to figure out what x is. Pythagorean Theorem is this. A squared, let me go back one. It's not capital A. It's always a squared, lowercase, plus b squared, lowercase, equals c squared, where c is the hypotenuse, and a and b are the legs of the triangle. The hypotenuse is always the leg that's across from the right angle. So in this case, this would be our c, and then we can label this one a or b. It doesn't matter how we did that. Okay? So let's just plug things in. I'm just going to copy this formula down here again. A squared plus b squared equals c squared. I told you that hypotenuse is always across from the right angle, so we know that's 500. We know a is going to be 300 squared plus b, which we're going to represent as x squared. Rather than doing this difficult math, and again this is squared right there, rather than doing this difficult math, I'm going to simplify things. I'm going to kick off these two zeros and I'm going to kick off these two zeros. It's going to preserve the same proportionality, but it's going to make the math much simpler. So let's go ahead and work this out. 3 squared, 9, plus x squared just becomes x squared. 5 squared is 25. Now we're just solving for x. We're going to subtract 9 from both sides. 9 minus 9 is 0. 25 minus 9 is 16. I'm left with x squared equals 16. To get rid of the square, we're going to do the opposite, which is square root. That goes away. It becomes x equals the square root of 16, which is plus or minus 4. Think about what we did up here. We took away 2 zeros, so let's add them back in. So x is equal plus or minus 400. Just adding those 2 zeros back in. And could we have a negative value for distance up? No, so we know it's going to be plus 400, which is right here. Your boss tells you to neatly stack a pile of boards behind a building. Each board is 8 feet long, 6 inches wide, and 4 inches thick. She tells you to place 4 boards side by side, then 4 more boards on top of those, and then 4 more boards on top of those, and so on to create your stack. When you're finished, the stack is 10 feet tall. How many pieces of lumber are there in the entire stack? So let's start thinking, let's draw ourselves a mental picture. We're basically stacking the pieces of lumber in rows that are touching. Specifically, we're stacking them in 4 piles. Okay. We know each piece of lumber is 6 inches wide and 8 feet long. This is not drawn to scale. So this is basically a top view. If you were standing on top of the building looking down at the lumber, this is what you would see. Stack 1, stack 2, stack 3, stack 4. Okay? If you were to look at the side of the stack, you would know each piece of lumber is 4 inches wide. That is, it goes up by 4 inches every time you stack a new piece of lumber in the pile. So in other words, 3 pieces of lumber stacked on each other would be 12 inches or 1 feet tall. Okay? So with that in mind, let's think about what the problem's asking. The stack is 10 feet high, and we know each piece of lumber is 4 feet wide, or 4 inches wide. Let's convert all this to inches first to make it simpler. So 10 feet is the same as 10 times 12. There are 12 inches in a foot. That's the same as 120 inches tall. Okay? If each stack is 120 inches tall, how many pieces of lumber are there in one stack? We know each piece of lumber is 4 feet tall, or 4 inches tall. So we do 120 divided by 4. 4 goes into 12. 3 times 4 goes into 120. 30 times. So in each stack, we know there are 30 pieces of lumber. Okay? We're asked how many pieces of lumber are there in the entire stack of 4. 30, 60, 90, 120. You have to carpet a room that measures 8 feet by 14 feet. How many square feet of carpet should you buy? Again, we're assuming the room's a rectangle. It's 8 feet wide by 14 feet long. Again, area of a rectangle is length times width. So in this case, it's going to be 14 times 8. Let's go ahead and work that out. 8 times 4 is 32. Bring the 3 up. 8 times 1 is 8 plus 3, 8, 9, 10, 11. So you're going to need 112 square feet of carpet. Patricia is twice as old as Laura. In 3 years, the sum of their ages will be 42. How old is Patricia? Okay. Patricia is twice as old as Laura. So I'm going to let Laura equal x years old. That means Patricia is going to be 2x years old. She's twice as old as Laura. In 3 years, the sum of their ages will be 42. So if we add 3 here and add 3 here, we know when we add them together, the sum's going to be 42. So let's go ahead and work that out. X plus 3 plus 2x plus 3 equals 42. Again, this is just saying L plus P equals 42. I let L be represented by X since we didn't know what her age, and P be represented by 2X since she's twice as old. 3 years affects both of them, so I had to add 3 to both of them. Okay, and that's how we came up with this. Combine like terms. We got X's here. X plus 2X is 3X. 3 plus 3 is 6. Equals 42. Let's subtract 6 from both sides. 3x equals, what's 42 minus 6? That is going to be 36. Divide both sides by 3. X equals 36 divided by 3. I'll do it the long way in case people can't see it. 3 goes into 3 once. 3 times 1 is 3. Subtract. 3 minus 3 is 0. Bring down the 6. 3 goes into 6 twice. 2 times 3 is 6. Subtract, no remainder, so x is equal to 12. So we know Laura's 12 because we represent it. We said Laura's x years old. Patricia is twice as old, so Patricia is going to be 24 years old. Train A is heading west. Train B is heading east at 4 p.m. They are 260 miles apart. Train A is traveling 70 miles per hour and train B is traveling at 60 miles per hour. What time will they meet? So we got train A somewhere over here. Got train B somewhere over here. We know train A is heading this way at 70. Now train B is heading this way at 60. And we know the total distance they have to travel is 260 miles. Question is, at what time or how long will it take them to meet, somewhere in the middle here. I don't like these problems because they force you to use distance equals rate times time and actually do a little cheat. Let me ask you to think about the problem like this. If train A is traveling 260 miles, that is the same distance as above, but train A is traveling at 130 miles per hour, how long will it take train A to go 260 miles? Isn't that the same question? Here they're traveling 260, albeit at different rates. Here train A is traveling 260, albeit at a combined rate of these two, or the same speed both of these are traveling. Okay? These answers would be the same. Okay? So whenever you see questions like this, you can think of them as one train traveling the same distance at a combined rate of the two trains. So let's go ahead and plug that into our distance equals rate times time formula. We're interested in how long it takes them to meet. So distance, they're both traveling 260. This train's traveling at 70, this train's traveling at 60. We have to combine those, so that's going to be 130 miles per hour, and that's the trick to this problem, times time. Okay? Solve for t, divide both sides by 130. 130 divided by 130 crosses out, so we're left with 260 over 130 equals t. Think about this. 13 times 2 is 26, so 130 times 2 is going to be 260, so we know t is going to be 2. Okay? Similarly, we could have done this, 260 divided by 130, could have crossed out this 0, could have done 130 or 26 divided by 13. You just have to see that that's 2, otherwise you would have to do the long division. So it's going to take 2 hours for these trains to meet, or if you viewed it as one train traveling the combined rate of them, it would take train A 2 hours to go 260 miles. So we left at 4, add 2 hours, 6 p.m. they'll meet. A store manager makes $35,000 per year. Of this, 28% is withheld for federal and state taxes, but he receives 52% of his withholdings back at the end of the year. When he files taxes, what is his net income for the year? So we got to take the taxes out of the $35,000 and then add back in 52% of that which we took out. So let's go ahead and do that. $35,000. He loses 28% to taxes, which is 0.28. Again, I'm going to move this decimal place 2 places over to make it 28 instead of 2.2 or 0.28, and I'm going to add those back in at the end. 8 times 0 is 0. 8 times 0 is 0. 8 times 0 is 0. 8 times 5 is 40. Carry the 4. 8 times 3 is 24 plus 4, 28. Bring down a 0 since we're starting a new line. 2 times 0 is 0. 2 times 0 is 0. 2 times 0 is 0. 2 times 5 is 10. Bring the 1. 2 times 3 is 6. Add the 1. That's 7. Add. 0 plus 0 is 0. 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 8 plus 0 is 8. 7 plus 2 is 9. Okay? Add the 2 decimal places we took away back in. 1, 2. So we know that 28% of $35,000 is $9,800. Okay? So we got to go ahead and take that away from the $35,000. But of this $9,800, he's going to get 52% back. So let's multiply this 98 times 0.52 to find out how much he's going to get back. Again, move this decimal over twice. We're going to add that back in. So that's 52 times 98. Add the decimals back in. 2 times 0 is 0. 2 times 0 is 0. 2 times 8 is 16. Carry the 1. 2 times 8 is 18. Plus 1 is 19. Bring down a 0 since we're starting a new row. 5 times 0 is 0. 5 times 0 is 0. 5 times 8 is 40. Carry the 4. 9 times 5 is 45. Plus 4 is 49. Add 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 6 is 6. 9 plus 0 is 9. 9 plus 0 is 1. Bring the 1. 4 plus 1 is 5. Bring back in our two decimals. So we know he's going to get 5,096 back after the 9,000's taken away. So basically he's going to have 35,000 minus 9,800 plus 5,096. Let's make this, we can either do it in 2 steps like that, or we can just do it in 1 step. Let's do it in 2 steps. 35,000 minus the 9,800 in taxes. Again, 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 8 we can't do. We have to borrow a 1 or a tens place from here. That becomes 4. This becomes 10. 10 minus 8 is 2. 4 minus 9 we can't do. Got to borrow a tens place. That becomes a 2. That becomes a 14. 9 goes into 14. 9 minus 14 is 5. 2 minus 0 is 2. So that brings him down to 25,200. Let's add the 5,096 back in. Okay. 0 plus 6 is 6. 0 plus 9 is 9. 0 plus 2 is 2. 5 plus 5 is 1. Carry the 1. So that bumps him back up to 31,296. Oh, did I make a mistake somewhere? Did I? That should be 0. Sorry about that. 5 plus 5 is 0. Carry the 1. So 3,296. NASA decides that it's a fine day to launch a rocket. The rocket blasts off at 3:52 p.m. At 3:55 p.m., the rocket has reached point A, 35 miles above ground level. At 4:10, the rocket reaches point B, 232 miles above ground level. Assuming a constant rate of speed, how fast is the rocket traveling between point A and point B? So again, we know we're working with distance equals rate times time. In this case, we're looking to find out what the rate is. How fast? Fast is rate. Let's draw a little sketch. Rockets take off from the ground. We're told that by the time it reaches point A, it's traveled 35 miles, and it blasted off at 3:52 p.m. It reached point A at 3:55 p.m. Then it continued traveling to point B. It reached point B by 4:10, and at that point it had traveled 232 miles. Okay? Now this 232 refers to the distance it traveled from the ground to point B. We want to find the distance or the speed it traveled from point A to point B. So what I have to do is take this 232 minus 35 to find just this A to B distance. So that's the first step. 232 minus 35. 2 minus 5 we can't do. We got to borrow a 10 from here. This becomes 12. 12 minus 5 is 7. 2 minus 3 we can't do. We got to borrow a 10's place. This becomes 12. That becomes 1. 12 minus 3 is 9. 197. So we know this distance is 197. Okay, so we have the distance aspect of this formula. We do not have the time yet. We know that at 3:55 it reached point A. and at 4:10 it reached point B. Well, 3:55 to 4:10 is a total of 15 minutes. Okay, so from point A to point B it took 15 minutes. Now we have the time part. Now we can solve for rate. Again, rate equals to find rate, we simply do distance equals rate times time. In this case, we know the distance from A to B is 197. We don't know what the rate is. The time is 15 minutes. Let's take a look at this. 15 minutes, miles per hour. Do you see a conflict? Minutes, hours. So to be safe, we have to convert this minutes to hours. Okay? And to do that, we divide it by 60. 15 minutes is the same as 15 over 60 hours. 15 times 4 gets you 60, so you know this is going to be a quarter of an hour or 1/4. So we know in terms of hours, we're working with 1/4 of an hour. Okay? To get rid of this 4, or 1/4, we multiply by 4. What we do to one side, we do to the other. This crosses out. We're left with R equals 197 times 4. Let's go ahead and work that out. 7 times 4 is 28, carry the 2. 9 times 4 is 36, plus 2 is 38, carry the 3. 4 times 1 is 4, plus 3 is 7. So this is 788 miles per hour. So if you didn't calculate the distance from A to B or convert minutes to hours, you would have gotten this question wrong. Igor wants to paint his back patio and front porch. The patio measures 14 by 12 feet and the porch measures 10 by 8. If each can of paint covers 48 square feet, how many cans of paint should Igor buy? So let's say his porch looks like this and his patio looks something like this, or vice versa. We know this one's 14 by 12. This one's 10 by 8. Again, we're looking for area of rectangles, so that's going to be length times width. And specifically, we're going to have to find the area of this shape and add them together. So in other words, we're going to have to do area equals 14 times 12 plus the area of 10 times 8. Let's go ahead and work that out, and then we'll be able to figure out where we need to go from there. So 10 times 8 is just 80. 14 times 12 we'll have to work out. 2 times 4 is 8. 2 times 1 is 2. Bring down a 0 since you're starting a new row. 4 times 1 is 4. 1 times 1 is 1. Add. 8 plus 0 is 8. 2 plus 4 is 6. 1 plus nothing is just 1. So we have 168 plus 80 for the areas of each respective shape. Now we add them together. 0 plus 8 is 8. 6 plus 8 is 14. Carry the 1. 248. So we know the area of the combined spaces is 284 square feet. We know one can of paint covers 48 square feet. So to find out how many cans he needs, we have to divide 248 by 48. 50. Imagine this 48 were 50. 50 times 5 would get us 50, 100, 150, 200, 250. Okay? So let's go ahead and multiply 48 times 5 and see how close that gets us. 5 times 8 is 0, is 40. Carry the 4, 20, 24. So 48 times 5 is 240. Again, 5 cans of paint would only cover 240 square feet. That means we wouldn't be able to paint 8 square feet. So we're going to need at least 6 cans of paint. Find the missing length in a right triangle where the lengths of the two known legs are 10 inches and 24 inches. We're told it's a right triangle. We're told the legs are 10 and 24 inches respectively. We need to find this measure, the measure of this length for this problem. In the previous problem, I told you that Pythagorean Theorem says a squared plus b squared equals c squared, where c squared, which is the length opposite the right angle, is the hypotenuse. So we'll go ahead and call this one a, this one b, plug it in and find c, or x in this case. So a is 10 squared plus b 12 squared equals c squared, which is the unknown length right here, the hypotenuse, which is across from the right angle. 10 squared is 100 plus 12 squared, which is 144, equals c squared. Oh, this is 24, not 12. So let's start over. 10 squared plus 24 squared equals c squared. 100 plus 24 times 24. 4 times 4 is 16. Carry the 1. 4 times 2 is 8. Add the 1. That's 9. Bring down a 0. We're starting a new row. 4 times 2 is 8. 2 times 2 is 4. Let's add 6 plus 0 is 6. 9 plus 8 is 7. Carry the 1. 17. Carry the 1. 576. So this is 576 equals c squared. 100 plus 576 is 676 equals c squared. To get rid of the squared, we take the square root of both sides. We're left with c equals the square root of 676. So we know it's going to be a whole number. Instead of doing, since I'm not very good with squares, let's just multiply this. We know 20 squared is 400, so we know that's too big. 30 squared is going to be 900, so that's too big. Let's go ahead and square 26 and see if that gets us that number. 6 times 6 is 36. Carry the 3. 6 times 2 is 12. Plus 3 is 15. Bring down a 0. 2 times 6 is 12. Carry the 1. 4, 5. 6 plus 0 is 6. 5 plus 2 is 7. 5 plus 1 is 6. So we know it's going to be 26 inches. Okay, so that's all I have for you today. Hopefully you found this guided practice helpful. If not, feel free to send me a private message, and also feel free to leave comments in the comment section below. But on that note, I will go ahead and cut you guys loose. Konnichiwa.